All right. Hello, everyone. I'm going to go through these questions on the board, and I'm actually obviously including the video as well. I apologize. I don't know if you see it backwards or I see it backwards on my screen, but either way, I'll post pictures with it as well so you can see. So, kind of taking a peek at these questions. I know some of you kind of reading through the examples kind of understand things, but this way I'll put some audio to it, and hopefully that will help just a smidge. So, kind of the first aspect of the quiz is looking at circular and periodic functions and kind of understanding what that entails. Okay. So looking here, I have a graph of a periodic function. You can see it repeats over time. We need to identify what the actual period is. So when I look, generally I'm going to pick a starting point, okay? And then we're just going to trace over. We're going to figure out where the pattern starts to repeat again, which is right here. And then we want to identify that horizontal distance it takes to complete one cycle. In this case, that distance is 4, so my period is 4. Okay, good deal. So that's kind of the first type of question, being able to identify the period. Second piece here, this question is just kind of getting at general shape of periodic functions. There's a few questions like this on the CPS as well. Okay, so if I look, at this situation, 5, 12 is a point on my graph. 5, 12 is a point on my graph. Okay, I don't care what the pattern is, but I know the period is 15. So whatever happens here, I know this point over here, 15 away, we're going to get back to the same point because that's the definition of a periodic function. It repeats itself every 15. So the question is, what's this value here? Well, what's 5 plus 15? That's 20. Okay. So if we can get that idea in our mind, then we should be able to answer this question. Okay. I want to figure out what the function's value is at negative 25. Well, if I'm thinking about this pattern, all right, this pattern is going to repeat both left and right forever. It's going to go over here. Sorry, this is bad picture here. But this is going to be at negative 10 because that was 15 away. Again, our period is 15. We're back at 12. If I go another 15 this way, that's going to be negative 25. What's the value of my function going to be? Well, surprise, surprise, it's going to be 12. Okay, so those are kind of the first key concepts, figuring out period or point values based on those circular and periodic functions. Okay, as we transition to sine and cosine, we kind of have that same concept, but now we know the general shapes of graphs. Sine starts in the middle, goes up and back down. Okay, and back to the middle. Cosine starts at a peak, goes down and back up. So when I look at this situation, I'm told that sine is my graph. So I'm thinking generally my sine wave goes up, down, and back up. That's where the solo comes from. Okay. So kind of thinking about things, I'm told the max value is at 9 pi halves, 5. Okay. So when I wrote this question down, I wasn't really um, it's obviously incomplete as far as things go. What I mean for this is I want this to be my graph. Sorry. And then the 3/4 value, 9 pi halves, is here. And then we're up at 5. Okay. So I didn't include that in the question here, but um, I was hoping for a negative a value. So if our sine value goes down, then back up, we know it's going to be a negative a value. So I know in this situation, I'm going to have a negative 5. That's my amplitude. Okay. Sine graphs normally start going up, back down, back up. This one, since I said 3/4 of the way through, I should have said that here. 3/4 of the way through my period, my max actually occurs at 9 pi halves. So the question is now, how the heck do I come up with my B value? Okay. Well, we know this is 3/4 of my period, right? 3/4 of my period equals 9 pi halves. All right. Well, if 3/4 of my period is 9 pi halves, if I multiply both sides by 4/3, those go away. I know my period is going to be, right? 4 divided by 2 is 2. 3 divided by 9 is 3. I wind up with a period of 6 pi. Okay. If we know my period is 6 pi, I know period's always 2 pi over b. I know that b would have to be 1/3. All right. So again, we're using that general shape of these graphs to come up with those values. Okay. Looking at this next one, we have a cosine value. Okay. So generally, I'm thinking cosine graphs start at the peaks and then go back up. Okay. I'm told in this instance, my minimum value is at 3 pi -4. Notice in both of these situations, we have no h and k values. We're not looking for h and k at all. Okay. So coming along here, we need to figure out what the heck is our period. All right. Obviously, in this case, since we start at the peak, go down to -4, my a value must be, hopefully you're thinking in your head right now, 4. We start at the peak, we go down. That's where the cholo comes from. Okay. So kind of figuring out that a value is the easiest, especially when there's no shift. Okay. So now we need to come up with this b value. Okay. Looking here on my graph, from high to low is 3 pi. So the question is, what's the whole period? And most of you can figure this out. This is half my period. So again, I know my period is 6 pi in this case. We know my period is always 2 pi over b, which coincidentally, we wind up with b is 1/3 again. So 1/3 x is the equation for this graph. All right. Continuing on. All right. Those are kind of just based on the general shapes as we go through things. Now we'll kind of look at actual graphing these functions. Okay. So as we go through things, I'll try to help identify. We're going to start with the sine wave. We know our a value is always a positive number. Okay. So really make sure we're actually stating a positive number. If you state a negative, you know it's wrong. Okay. B is always, or your period is always 2 pi over b. B in this case, it helps if you write it in factored form. So I'm going to divide by 1/2. I'm going to divide by 1/2. And there we go. So we're taking the 1/2 out of each. We have theta plus pi. Sorry, that should be a plus pi left. So I'm dividing by 1/2. 2 pi divided by 1/2 is 4 pi. Okay, so I know my period on this graph is 4 pi. Looking at my equation in factored form, we have plus pi. If I'm adding pi, I'm shifting my graph left pi units. If I have a -1, I'm shifting it down 1. Okay. So those are all kind of key points on our graph. So I know that my midline is going to be down at y equals -1. All right. If I know my amplitude is 2, I'm going to go up to 1. -1 to 1 is 2. And I'm going to go down to -3. Okay. So all of this information we can set up from figuring out these 4 things. Additionally, I'll be able to use my period. Okay. So typically, we'd go out to 4 pi. We have 1 pi, 2 pi, 3 pi, 4 pi, right? I'm going to leave it like that, and I'm going to put 1 over here, and you'll see why in a second. Okay. So start at 0, go out to our period from there. Keep in mind, we're shifting all of our points left pi. All right. So as we go through things, we can start to graph and pull this together. So normally if this was 2 sine theta, right, we'd be at 0. Okay, we start at 0. If you remember your general sine wave, start at 0, go up, down, and back up. Okay, but this starting point, remember we shifted down 1 and we shifted left pi. So my starting point is going to be at negative pi, negative 1. Okay, we know that our graph is going to go up a quarter of the way through. So a quarter of the way through is going to be pi. Pi, we're going to be up at positive 1. Then we're going to continue that pattern down to 0, down to negative 3, back up. Now I obviously could continue my pattern. All right. So at 4 pi, I'm going to be up at 1. All right. And then we have our sine wave graphed. Okay. I do want to show you how to use the table. Okay. Just because we have everything set here, maybe using that method and understanding the shape just isn't gelling with you, which is totally fine. So we'll go old school. Okay. We go 0 to 4 pi, 2 pi, pi, 3 pi. So we set up our table from 0 to period, and then we cut it in half, and then we cut it in quarters all the way across. Okay. Like I said, with a normal sine wave, I'm thinking so ho low. So 0, high, 0, low, 0. The reason I use 2 and negative 2 is because A is 2. Okay. If it was negative, then I would have those flip-flopped. Okay. At this stage, once you have this information down, then we can adjust. All of our x values, we're shifting left pi units. So I'm going to subtract pi from 0 to get negative pi. Pi minus pi is 0. Pi minus 2 pi is pi. 3 pi minus pi is 2 pi. 4 pi minus pi is 3 pi. And notice the first 5 points we graphed are from negative pi to 3 pi. Okay? We also have to factor in a shift, a vertical shift of 0. So I'm going to shift all of these points down 1. 0 minus 1, 2 minus 1, 0 minus 1, negative 2 minus 1, 0 minus 1. And if you notice, negative 1, 0, 1, pi negative 1, 2 pi negative 3, and then 3 pi negative 1. Okay? So if it helps to just do the table, then do the table. And then you want to subtract from your x coordinates or add any phase shift. And then your y coordinates, you want to add or subtract any vertical shift. Okay. You don't have to do this every time, but if it helps, please do. If you understand the general shapes of your graphs and you just go into town and labeling things and remembering those acronyms, if that method works for you, great. If you have to do table, do whatever works for you on these. Okay. So kind of coming around to the next one here, looking at our amplitude. Again, amplitude is always stated as a positive value. So my amplitude is 4. Sorry, let me shift this a little bit so you can see. All right. We want to factor. So we're factoring out a 1/3. We have theta minus 4 pi plus 1 is kind of what we get in factored for. So I'm taking out the 1/3 from each of those. Okay. So again, a values here. My period is going to be 2 pi over 1/3, which is 6 pi. Okay. Something to kind of keep in mind. Our phase shift, we're moving right 4 pi. Again, our h value is indicative of that. This plus 1 off to the side means we're moving up 1. Okay. So kind of just like before, I'm going to set up my graph. Y equals 1 is going to be my midline. I'm shifting everything up 1. Okay. I know my amplitude is 4. So from 1, I'm going to go up 1, 2, 3, 4. And this is going to be 5. I'm going to go down 4. 1, 2, 3, 4. All right. And then from there, we know my period is 6 pi and my shift is 4 pi. So we want to kind of keep that in mind as we go through things. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So I just did this 1, 2, 3, 4, 5, 6. So I have at least a full cycle in there. And then I have my pi's to work with. So I'm going to say 2 pi, 4 pi, 6 pi, 8 pi, 10 pi, just to kind of give us a little bit to work with. All right. So I'm going to do kind of a hybrid of these ideas. Actually, I'm do mainly graphing these points. So thinking about things, normally, all right, we're going to start a cosine graph at its peak, but since we have a negative value, we're going to start at its valley, correct? So we'd start down at this low point, correct? For this low point, we shifted right 4 pi and up 1. We've already taken account for that up 1 piece, so it's not down at -4, it's at -3. And I'm going to shift that low point over 4 pi. Okay. So there's my low points. Okay. We know that 6 pi away from this, so at 10 pi, right, I'm back at that same point. I could also go the other way, 1 pi, -2 pi, and I know 6 pi away from this, I'm at that same point. Okay. So I'm trying to kind of help you kind of see that pattern. Every 6 pi away, I'm going to be at that same point. All right. Keep in mind, halfway through my period, so what's halfway between 4 and 10? Well, that's going to be 7 pi. I'm going to be up at that max value. Okay. Again, keeping in mind the shape of the cosine graph. So I know that every 6 pi again, I'm going to be back at that same point. If I go this way, I'm going to be off the table. If I go this way, that's going to be 1 pi and be back up at 5. Okay. Again, trying to keep that general shape in mind. Okay. So now the question is, where are those halfway points? Well, what's halfway between 4 and 7? 5.5. So I know at 5.5, I'm right up there at the 0 at the midline. Okay. Halfway between 7 and 10 is going to be 8.5. We're at that midline. 8.5 minus 6.5, right? It's 2.5. 2.5. I'm at that midline, 2.5 pi. All right. 5.5 minus 6.5, -0.5 from there. All right. So notice we're just using that general shape. Oops, that one didn't go down all the way. To copy and create that shape. Okay. So hopefully that kind of helps give you a little guidance of things. Notice as I go through things, I'm using the pattern, I'm using the shift, I'm using my understanding of general shapes of periodic functions to come up with things. Okay, but I'm using all that information and putting it together to make the graphing process a little easier. All right. Coming up on this next one here. All right. So tangent seems to give people the most difficulty as far as things go. We know there is no amplitude. Sorry, I'll try to stick to the same colors. So green, there's no amplitude. Looking at this one, we have -2, tangent. If I'm factoring out a 3, I'm shifting this graph pi 6 over. So that's going to be left pi over 6. And I know my vertical shift is 2. Okay. From here, looking at my period with tangent, it's always pi over b. In this case, it's pi over 3. Good deal. All right. The one thing we do want to take into account all right, is where those asymptotes occur, okay? Remember, our asymptotes typically are divided in half, or a period divided in half. So we're going to be at positive and negative pi over 6. But we are shifting them left pi over 6. So if I think about this, okay, and I'm going to have asymptotes at negative pi over 6 and pi over 6, and I'm shifting them left pi over 6, pi over 6 minus pi over 6 is going to be 0. So I'm going to have an asymptote at 0. I'm also going to have negative pi 6 shift over to negative 2 pi over 6, which is negative pi thirds. And I'm going to have another asymptote. Okay, and notice the distance between 0 and negative pi over 3 is pi thirds. Notice with my tangent graph, what's right in the middle here? Negative pi over 6, which is exactly my shift. That makes sense. Okay, now I just need to figure out those halfway points. Half of the 6 is a 12th. 1/12, 2/12. This would be negative 3 pi 12ths. Okay, then I just need to come up with my values. Okay, notice this time I have a negative tangent. So normally tangent graphs go up to the right. Okay, this one's going to go down to the right. All right. Again, normally, I'm not going to set up the table, but normally we start at 0, correct? But we shifted the point left pi over 6, and we're shifting it up 2. So I'm going to be, sorry, I'll change this value so we don't see. All right. So I normally am here. I shifted my point left pi over 6 and up 2. Okay. So that's the center of my tangent graph. Normally, my next point, I'd be down. But since we have a negative value, I know I'm going to start up. So at my halfway point, I'm going to be 2 above at 4. At my next halfway point, I'm going to be 2 below at 0. And then we can create that graph. All right. If I need to repeat a cycle of tangent, I know that I'm going to be pi thirds away. So this is positive pi over 3. I know that that's going to be pi over 6, which makes sense because these points repeat every pi thirds. A third and a third is a sixth. Okay. Or sorry, a sixth and a sixth is a third, rather. Okay. Then I know I'm going to be at pi over 12 and 3 pi over 12. And that totally makes sense because if I think about a 12th and 3/12, what's 1/12 plus 3/12? That's 4/12, which is pi over 3. So this point is going to repeat pi over 3 units away. This point is going to repeat pi over 3 units away. This point is going to repeat pi over 3 units away. And there's another cycle of my tangent graph. Okay. Again, continuing on, we just have a last few questions here. So kind of looking at our general shape, we're given a graph. It goes down to 3 and up to 7. It looks like peak to peak is going to be between pi fourths and 5 pi fourths. So this is all kind of good information to kind of look at. So first thing I'm looking at is where the heck is the middle of 3 and 7? Well, I know that's 5. Okay. So I know immediately my K value, my graph shifted up 5 units. I can also figure out my amplitude. That's the next easiest thing to figure out. From 5 to 7 is 2. From 5 to 3 is 2. So I know this is going to be 2. Okay. Keep in mind, cosine graphs normally start at a peak. Okay. So I'm going to kind of eyeball that as my starting point. Pi over 4, 7. Cosine values always start at the peak. So that's kind of where I need to go next. Okay. I notice it shifted off 0. It shifted off 0. How much? Pi fourths. I shifted right pi over 4. Sorry, I was using x. Whoops. All right, so if I'm shifting right pi fourths, I'm going to go minus pi over 4. So that accounts for this shift. Now the question is, how the heck do I figure out my b value? Well, I need to use my period. I know that 4 pi over 4, right? 4 pi over 4, which is just pi, equals 2 pi over b. So if I flip-flop those, I'm going to get b equals 2 pi over pi, which is 2. So my b value is 2. So notice on these types of questions, when you're given a graph, it's easiest to start with a and k. If you know the midline and amplitude, you're good to go. Then you'll want to account for your period and your horizontal shift from there. But that is the equation of this graph. It's easiest, like I said, to break those down and find one thing at a time, so you're not trying to find all 4 things at once and confuse yourself. One thing at a time. All right, these last few questions. Sorry, I gotta move my table. Move this picture a little bit. Okay, so kind of looking at these last 4, notice -4/7 is not on the unit circle. So what I'm going to do is I'm going to draw a picture. I know tangent inverse. Sorry, you're like really close there. I know tangent inverse is defined in quadrant 4. So that's where I'm going to draw my picture. I know tangent inverse is here. If I'm looking at opposite over adjacent, that's going to be my picture. Okay. So that's how I set things up. Again, I use my understanding of tangent inverse to sketch my triangle because this is not on the unit circle. All right. At this stage, I'm then thinking, how do I get the third side in my right triangle? Remember, our hypotenuse is always positive. Okay. So 49 and 16, we can't simplify that out. So that's just going to be the square root of 65. Okay. From here, we're looking for my cosecant value. So thinking about this triangle and using this angle, cosecant is the reciprocal of sine. Okay. Sine is normally opposite over hypotenuse. Okay. So I'm thinking, what is my hypotenuse over my opposite side? And that is your answer. Okay. So again, this wasn't on the unit circle. Sketch a picture to create your triangle, and then you can use that triangle to come up with your ratio. Okay. If this is on my unit circle, it makes things a little easier. So again, we're using the definition of inverse. I know inverse cosine is going to be in quadrants 1 or 2. Okay, so I'm looking for where on my purple sheet is cosine inverse -2/2, which is up here. Okay, so I'm thinking, remember, inverse function gives me an angle. This angle is 3 pi fourths. So now I'm thinking, what is the sine at 3 pi fourths? Well, the sine at 3 pi fourths, again, I'm looking at this angle, 3 pi fourths. What's my sine value? It's square root of 2 over 2. Okay, so unit circle values are a little easier. You obviously can use your purple sheet, figure out the angle, and then you want to figure out the ratio based on the angle you just found. Super important. Tangent inverse is in quadrants 1 and 4. Sine inverse is in quadrants 1 and 4. Cosine inverse is in quadrants 1 and 2. I will not have you do secant, cosecant, cotangent. Okay. Last values here. These ones always tend to trip people up. Again, I have 2 examples, one unit circle, one non-unit circle. So the unit circle is super easy. Looking around one revolution or one rotation of my unit circle, I'm thinking about where's my sine value. Again, the y value is positive, √3/2. I always like to sketch just to kind of help keep my mind set. I'm looking at where my sine values are, √3/2. They're here and here. So the question is, what are those 2 angles? My 2 angles are pi over 3 and 2 pi over 3. Okay. Some of you might be wondering, well, why the heck did he not say 60 degrees and 120 degrees? Well, right there in the directions of the question, it says find your angles between 0 and 2 pi. So that's why I used radians to state my answer. Same deal here. All right, I'm looking for where cosine or my x values are negative 0.5. Okay, so in one rotation of my unit circle, again, I'm using radian mode. So I need to check and make sure my calculator is in radian mode. I'm going to do the cosine inverse of negative 0.5. So cosine inverse negative 0.5, and I get 2.094. Okay. Thinking about where cosine is negative, I know it's here and I know it's here. So I need this angle, which we just found is 2.094. Okay. I need to find this angle here. In order to find that angle, I actually need to figure out my reference. Okay. I need to figure out what the heck that is. Keep in mind, this is pi units. So from here, I'm going to do pi minus 2.94 to get this angle, which is 1.07 or 047. The reason I need my reference angle is so I can figure out what angle is actually in quadrant 3. This is also 1.047. So now I'm going to add that to pi to get this angle from standard position. So if I do pi plus this, I wind up with 4.189 is my second angle. Again, I get my two answers. I get where x is negative in quadrants 2 and 3. Keep in mind pi is 3.14, all right, which makes sense that this is less than 3.14, and it makes sense that this is greater than 3.14 based on this being pi radians. So we're all set up. Again, I strongly encourage you to draw a picture, okay? That's going to be the work that helps set those that get it correct from those that get it incorrect. All right. So we kind of have a good spread of problems. Again, I thought this would be helpful if you need to actually see the work. If it's backwards on the video, my apologies, but I'll make sure to post pictures as well. So best of luck. I hope everybody gets an A on the quiz tomorrow.